Hello, my name is Nicolas Abella and I'll be representing my team solving point 5 and 6 of our exam.
So, first of all, I'd like to start with a brief resume about oligopoly. Oligopolies are markets dominated by a few large firms. For example, Apple's iOS and Android are an oligopoly for operating systems on smartphones and tablets. This is maybe one of the most important characteristics of oligopoly. There's also that firms are interdependent. This means inaction by one affects the others. An example of this can be firm 1 that has a huge market share on, let's say, candies. So if firm 1 decides to raise its price, let's say 20%, the original one, this action will end up affecting the others. Next we have that they have to decide whether to collude or to compete. Sometimes it's important to say that collusion is illegal in some countries, so this is a reason why oligopolists are forced sometimes to compete. And finally, we have that game theory can be used to explain oligopolists' behavior. Here we have one of the clearest and most common example of game theory introduction, which is called the prisoner's dilemma. The prisoner's dilemma will help us understand the reasons why sometimes oligopolists decide to collude or to compete. So it's important when we are asking ourselves when and why to collude or to compete. When oligopolists decide to compete, there's two options. They can compete in prices or they can compete in quantities. If they decide to compete in quantities, we have two models to help us understand their behavior. When we want to study oligopoly, we have to make the assumption, or to simplify the process, there are only two firms on the market. In this way we are analyzing a duopoly. And for this, when oligopolists compete in quantities, we can use Cournot's model or Stackelberg's model. In Cournot's model, both firms decide on a quantity to produce independently and simultaneously. What this means is that they don't have any agreement on how much to produce, and they make that decision at the same time. While in Stackelberg's model, we have that one firm decides first on the quantity they will produce, which in some books it's called the market leader, and the other one decides based on that, which is also called the market follower. For these two models to work, we have to make the assumption that products are identical and that firms decide not to collude or they can't. As I said at the beginning of the presentation, that sometimes in some countries collusion is illegal. So now that we've explained the basics of oligopoly and Cournot's and Stackelberg's model, we can proceed to solve the problem. Problem 5 says, two duopolists compete in quantities with homogeneous products. For both, total costs equals 4 times Q. The industry's inverse demand function is price equals 16 minus 2 times Q. The quantity that each would produce in Cournot model would be, and they give us a bunch of possible answers from which we'll have to decide. To make this a little bit more dynamic, I'm going to be making the assumption that firm number 1 is Boeing and firm number 2 is Airbus. In the modern market, it's really hard to find pure duopolies, but Boeing versus Airbus is maybe the purest and more precise duopoly we can find. So first of all, we'll have to find the profit equation for Boeing and Airbus, and when we do it, we will derive it equally to 0 and find the best reaction curve for both of them. So we know that the profit for let's start with Boeing. The profit for Boeing is given by total incomes minus total costs. We know that total incomes is price times the quantity minus total costs. We know that price is given in the problem as the inverse demand equation, the inverse demand function, sorry, and total costs is given right here in the problem again. So in this case we will just only replace both of them like it shows right here, and here we'll apply distributive property, and we'll end up having the following expression. We can simplify this by subtracting 4q1 to 16q1, and we'll end up having profit equation simplified. After we have this equation simplified, we will derive it as it follows, and we'll end up having that derivative of profit of Boeing's profit is minus 4q1 plus 12 minus 2q2. We now equal that equation to 0, and we will solve for quantity 1. When we solve for quantity 1, we'll end up having Boeing's best reaction curve, which is the quantity that it should produce given that Airbuses produced this quantity. So we'll have to repeat the same process with Airbus or firm 2, and so we know that the profit of firm 2 is equal to the total incomes this firm minus the total costs of this firm. So we know that this can be expressed as price times quantity minus total costs. We already know the value of price and this one, total costs. So we apply again distributive property, and we'll end up having this equation. We can again simplify it by subtracting 4 times q2 to 16q2, and we'll have the profit equation simplified, which is equal to minus 2q2 squared plus 12q2 minus 2q1 q2. Next step is to derive the equation and equal it to 0. When we do this, the next step in this case will be to clear for quantity 2, not quantity 1, because this is going to be the best Airbus's best reaction curve. So right here we just clear for Q2, which is an easy process, and we'll end up having Airbus's best reaction curve. So after finding both Airbus and Boeing best reaction curves, we can graph them. We can graph them right here in a Cartesian plane, where the x-axis stands for the quantity 1 and the y-axis stands for the quantity 2. Right here we have Boeing best reaction curve, and right here we have Airbus best reaction curve. There's a point at which both meet. This exact point is the quantity they should produce in the Cournot model. The point is given by 2, 2, we have it right here, but we can obviously find it algebraically by solving the equations, because we have that quantity 1 is equals to 3 minus 1 over 2 quantity 2, and quantity 2 is equal to minus 1 over 2 quantity 1 plus 3. In this case we could use quantity 1 and replace it in the best reaction curve for Boeing or firm 1, and so we end up having this equation. In this equation we apply again distributive property like this, and we'll end up having that quantity 1 is given by 3 plus 1 over 4 times q1 minus 3 over 2. We can subtract this to this one on the other side, and we'll end up having that 3 over 4 times quantity 1 is equal to 3 over 2. In this case, we can just pass this 4 multiplying. We'll end up having that 3 times quantity 1 is equal to 6, and we'll just divide 3 to both sides, and we'll know that quantity 1 in Cournot model is equal to 2. Now that we have the quantity 1, we can replace that quantity 1 in the best reaction curve of Airbus. So we can replace it right here like this, and we'll have that right here. We just multiply. We know that minus 1/2 times 2 is minus 1, and we just add 3. We know that quantity 2 is 2. If we want to make this like a little more realistic in terms of, well, the example we're using, we can make the assumption that each unit stands for 100 airplanes produced. So for example, in Cournot model, the quantity produced by both firms will be 200 airplanes. So now that we already have both quantities, we can use them to find the quantity produced in the market and the price of the airplanes in this market. So we'll have that quantity, total quantity, is equal to quantity 1 plus quantity 2. And we know that quantity 1 and 2 are both 2. So we add 2 plus 2 is equal to 4 right here. And we have the inverse demand function where we'll just have to replace for quantity, total quantity. And we'll end up having this equation, 16 minus 2 times 4, which is 8. So 16 minus 8 is equal to 8. This will be like really useful when we graph the situation of the market. So now that we know that quantity 1 and quantity 2 are both true for 200 airplanes, we can conclude that the answer for the question is 2, or B. So now we'll be solving problem 6, which says, for exercise 5 in the Stackelberg model, firm 1 chooses first the quantity that firm 2 would produce, the one that chooses second would be, and they give us again a bunch of possible answers from which we'll have to decide again. So in this case, as I told you, I'd like to call Boeing, the firm that chooses first, the leader in the market, and Airbus, the one that chooses the second, the follower of this market. So in this case, we'll be using the best reaction curve that we found earlier in exercise 5, in problem 5, sorry, which are given by this equation and this equation. And as we know that the leader is Boeing, or firm 1, we'll be using its profit equation as we already calculated it, and we'll be replacing the quantity 2 by the best reaction curve of Airbus, or firm 2. So we'll end up having the following equation, in which we'll apply the distributive property again, and then simplify the equation, well, subtracting the 6 to the 12 and adding the 1 to the 2, because they are the same terms. So we'll end up having that the profit equation is this one. Profit equation for Boeing is minus Q1 squared plus 6 times Q1. We know that we can maximize its profit by making it equal to 0 and clearing for quantity 1. And so we know that this quantity is the one that maximizes profit. In this case, we'll just place the 6 on the other side, subtracting, and we'll divide both sides by -2, and we'll end up having that the quantity produced by the leader is 3, or in the example we're using it's 300 airplanes. Now that we have the quantity that the leader will produce, that Boeing will produce, we'll just come back right here in the Airbus's best reaction curve and replace it right here in Q1, quantity 1. We know it's 3, so we just replace it and multiply. 1 over 2 times 3 is 3 halves, and we know that it's 3 adding, so we'll have that minus 3 over 2 plus 3 is equal to 3 halves, or 1.5. So we know that is the quantity 2 on Stackelberg's model. We also know that on our example, this stands for 150 airplanes. So in this case, Boeing will be producing 300 airplanes and Airbus will be producing 150 airplanes. Right here we can find also the total quantity produced in the market, which is quantity 1 plus quantity 2. So it is 3 plus 3 over 2, which is equal to 9 over 2. And we can also use the inverse demand function, which is 16 minus 2 times q, which we already have. We just multiply, the 2 cancels out, and we'll have that 16 minus 9 is equal to 7. This will be the total quantity of the market right here, and the price of the airplanes on the market. Let's say the price stands for, each unit stands for $10,000 or $100,000, so it's maybe $700,000 an airplane. And so we know that if they ask us for the quantity that the firm 2 would produce as the follower, we know that firm 2 as the follower will be producing 3 halves or 1.5. And so we know that the answer for this question is A, 3 halves. And finally, with this information, we'll be able to graph the situation of the market, the inverse demand function, and the prices and quantities that each model is going to be handled. So for example, in Cournot model, we'll end up having a price of 8 while the quantity is 4. While in Stackelberg, we know that the price is 7 and the quantity is 9 over 2, or 4.5. And finally, I'd like to make a brief resume and a comparison between the Cournot and Stackelberg model. In Cournot, we can see that both firms had the same profit. Boeing had a profit of 8 and Airbus had a profit of 8, which add up to a total profit of 16 for the whole market. While in Stackelberg model, profit for the leader, or Boeing, which is firm 1, was of 9, while the profit for firm 2, or the follower, which was Airbus, was of 9 over 2, or 4.5, adding up to a total profit of 27 over 2. What can we conclude from here? We can conclude that Stackelberg model in this case gave or benefited the most firm 1, or the leader in this case, which was Boeing. How can we know that? Because profit increased from 8 to 9, and the profit of firm 2, or of Airbus, decreased from 8 to 4.5. And finally, we can see that the total benefit of the market decreased on the Stackelberg model. It passed from being 16 in the Cournot model and ended up being 27 over 2. And so we can say that the Stackelberg model benefits the most the leader firm, which in this case was Boeing, but the follower and the market as a whole sees kind of a decrease in its profit.